In this lesson, we're going to look at the simplest form of data visualization. We're going to look at the histogram. So to motivate this a bit, let's start with some data about bank employees. So here we have a spreadsheet, and on the far right, we have information about salary. Now, as a starting point, we might want to understand a little bit about the distribution of salary within the bank. So one of the things we can easily do within Excel is to calculate some descriptive statistics. But if we look at these descriptive statistics, we see something, the mean is almost $40,000. The standard deviation is $11,300. That's great, but it's not necessarily super intuitive. As human beings, we are very good at grasping patterns when we see them visually, and perhaps a little less good at grasping patterns in tables of numbers. So what we want to do in this lesson is transform the data into what's called a histogram. Now, histograms are always the same. Along the horizontal axis, we have the variable of interest, which in this case is the salary of the bank employees. And on the vertical axis in a histogram, you have some measure of frequency, either the number of employees or the percentage of employees. And each of the bars then corresponds to the number of employees or the percentage of employees that fall within that salary category or that salary bin. So if you look at the data here, you can see that the mean and the standard deviation really don't tell the whole story. There's a more interesting story here, which is that the bulk of the employees in this firm don't make very much money, but at the high end, you've got a very small number of employees who make much more money. So this isn't any recognizable distribution. It probably corresponds to a lot of worker bees at the bottom of the organization or new employees at the bottom of the organization, and then top management at the high end of the pay scale. Before we get into building a histogram in Excel, we're going to use Excel's built-in formulas to do a bunch of very simple data analysis. What I'm going to do is create a table of descriptive statistics. So what I really want is the mean, the median, the standard deviation, the max, the min, and the range. So what I want to do then for something like mean is use the average function that comes with Excel. And like any function, it takes an argument, which in this case is a range of values. Now what I'm going to do is I'm going to cheat and use Shift and then down, and that's going to highlight a whole range. That's a very useful trick when you have a bunch of data. And then I'm going to close the bracket, and there we see I've got the average function, and the argument is I2 to I209. Now before I hit enter, I'm going to hit Control C to copy that because I want to use that range over and over again. So what I have now is the average salary of employees at this bank. Now I can do the same kind of thing with median. Control V to paste that in, and you see that the median is $35,000, which means that exactly half the employees make less than $37,000 and exactly half make more than $37,000. Standard deviation, use the built-in formula. Max and min, same idea. Here's my max, here's my min. Now range is simply whatever it is, the maximum value minus whatever's in this cell, the minimum value, and that equals $70,000. So very quickly and fairly easily, I've created a nice little list of descriptive statistics, but like I said before, that doesn't really tell you a whole lot about the data. Creating a histogram in Excel is a little bit more difficult than you might expect, and that's because a histogram is just a column chart in Excel. So what you have to do is take your raw data and transform it into what's called a frequency table to be able to create the histogram. So here you see a very simple frequency table, and it has two columns. The column on the left is typically called the bin, and what it is a bunch of thresholds or cutoff points for the value of celery. And I'll explain that in a second. On the right hand side we have the count, which means Excel goes off and counts the number of values that meet the threshold. So let me give you a quick example and you see how this works. So in the bin column, the first number is 34, which corresponds to a salary at the bank of $34,000. And right next to it on the right hand side is a count of 60. What Excel does is it goes off to the data and it counts the number of values that are less than or equal to 34. In this case, there's 60. Then it goes to the next row in the frequency table, in this case 41, and it counts the number of data values that are less than or equal to 41 but greater than 34. In this case, 71 bank employees meet this criterion. So it goes all the way down to 97, which is the maximum salary, 97,000. In this case, there's 3 employees who make between $97,000 and some amount just over $90,000. So you have to really understand those cutoff points to understand how the frequency table works. Now the next part of it is those bin numbers get put along the bottom on the horizontal axis, and the counts become the frequencies on the vertical axis. Here I'm going to create a frequency table in Excel. Now normally when you create a frequency table you have to decide on how many bins you want, and I'm just going to use 10. As a rule of thumb, 10 is a good number. It might be too many, it might be too few. It's not particularly scientific. And then what I do to cheat a little bit to make sure I have the correct range along the horizontal axis is use the min and max to make sure I get the right size bin. So in this case my range is 70.3 and I want 10 bins, so I can sort of calculate how wide each bin is going to be exactly. So each bin is about $7,000 wide, and of course the bins have to be equal width for the histogram to make any sense. Now I'm going to use this space down here to actually create the bins, and just to keep track I'm going to number them. So I've picked up 1, 2, and I've grabbed the bottom corner here, and I can scroll down and get my 10 bins, and I'm going to put the word frequency here to keep track. So here's where I'm going to have my bins. Now I don't want to have the minimum, which is 26.7, as my first threshold, because I know there'll be exactly one employee that matches that criteria. What I want is a larger bin, so I'll show you how this works. So I'm going to put in equals the minimum plus the bin width. So now I'll have at least one item in that bin and possibly a few others. Pretty much everything between 0 and 33.73 will be the first bin. The second bin will be whatever in this bin plus the bin width. And I'm going to use F4 to make that an absolute address. So now I can just copy this down, and you'll see when I get to the bottom that my 10th bin corresponds to my maximum, 97,000. So that's the easy part. What I'm going to do now is use the frequency function provided by Excel to actually create and finish this frequency table. Now the frequency formula is a bit weird. It's probably different than any other formula you've seen in Excel because it's what's called an array formula, which means you have to work on an entire array of cells at the same time. And that sort of makes sense because when you think about it, this frequency function is using all the bins to calculate the counts. That is, it looks at the thresholds and counts the number within each threshold. So it has to be sort of considered as a whole. That's the way I remember it. So what I'm going to do is highlight the entire range beside the bins and then type in frequency to get the formula. So the frequency formula requires two arguments. The first is the raw data, the things we want to count, which in this case are the different salaries of our different bank employees. And the second argument is the bins array, which is what Excel calls it. And that's why we've been using the term bins. So I'm going to start by selecting my data, go back up to the top, get salary, shift and down, and then I press the comma, and then I scroll back up to get my bins array. So get all my bins and close the bracket. Now, the important thing to remember about an array formula is I can't just hit enter now. If I hit enter now, this won't work. I have to remember to hit Control Shift Enter, and that will enter the array formula. So apart from some wonky alignment there, I get pretty much what I want and what we saw before. Now that the hard part's over, the easy part is creating the actual histogram. So before I do this, I want to show you a problem. Say I had put the word bins or something here. Now that looks like not a problem, it's just labeling a column, but that prevents me from creating the correct chart. So if I want to create a column chart and I select the first option, I don't get at all what I want. So I just delete that and show you the trick. If I delete the word bins here and leave the horizontal axis empty, highlight everything again, insert column graph, I get almost exactly what I want. Now you can see here I probably shouldn't have called that row frequency because it's not very descriptive, but I can change that later. The last thing we should talk about with respect to histograms is the difference between frequency and relative frequency. What we have so far is the frequency, the number of bank employees that fall within each salary bin. What we might want instead is a relative frequency, that is a proportion or a percentage. This becomes especially important when we start to do visual gap analysis and we want to compare two samples of different sizes. To add relative frequency information to your table, you start by calculating the total number of employees, which we know is 208. And I put that at the bottom, and then I use that number as the divisor. So I divide 60 by whatever is in this cell, and I hit F4 to make that absolute. Now I can also format this and make sure it is a percentage. Get rid of the decimal point places. And then I can just copy it down. And if I want to be sure, I can just copy that sum over so that I can see that all these frequencies add to 100%.